Hi, welcome to this session on speed learning. In speed learning sessions, we do not elaborate a lot on theory. We assume you know the theory. We are only going to cover standard scenarios or questions. Those scenarios and questions which can be adapted and presented in many different question forms. Knowing these beforehand gives you a big head start and you can solve questions very fast. Today's standard scenario involves a square ABCD and the vertex A is joined to the midpoint of BC. Let's call it E. The vertex B is joined to the midpoint of CD. Let's call it F. So both are midpoints. And look at this construction now. You're going to see the scenario in many different questions. Some of the learnings that you could commit to memory right away, and the first one is going to be triangle ABE is congruent to triangle BCF. Now this is a no-brainer. Both are right angle triangles with the vertex of the square being right angles, and the perpendicular sides are side of the square, half side of the square, side of the square, half side of the square. So by construction itself that they are congruent. Further, you could also say that the area of these are going to be 1/4 the area of the square. How is this? Just imagine a line passing through F parallel to the two sides, opposite sides, right? Since it is a midpoint, the line parallel divides the square into two equal areas. So the lower half is going to be half of the square. And the lower one is a rectangle. BF is going to be a diagonal. So the diagonal divides it again into half. So half of half is nothing but 1/4. So a pretty easy one to begin with. Now that they are congruent, here comes a bigger part. Because they are congruent, if I take BAE to be theta, then FBC will also be theta. Right? And watch here. In ABE, one angle is theta, one is 90. So the third angle has to be 90 minus theta. Now this is an important part. Why is this important? Because theta 90 minus theta means the angle formed at the intersection G is going to be 90. So big learning is going to be the angles at G, the intersection, are all 90 degrees. A major part there, right? And well, you could arrive at this in the other way also. This angle vertex B is 90, this is theta, so the angle above is going to be 90 minus theta. Now if I take ABG, there also I have a theta, 90 minus theta, and the third angle has to be 90, right? And if it is 90, if you are really good at pattern picking, you should realize ABE is a right angle triangle, and from the right angle vertex, I've dropped a perpendicular to the hypotenuse. That itself is a standard scenario, right? There's a speed learning session on that, and there are many relations that you could be very fast over here. And what are those relations? For example, if you want to find the length of BG, you should be very fast. AB into BE is equal to AE into BG. Anyway, those are covered in another lecture, so I'm not worried about that right now. Let's continue on what I want to teach you here. This triangle will be a part of many questions. Now that there are so many right angle triangles with theta 90, 90 minus theta, obviously similarity is going to have a role to play. So the third important result is triangle BGE. BGE is similar to BCF, triangle BCF. And what is the ratio of their sides? Let's figure that out, right? What do I know in BGE? Which side do I know in BGE? I know BE. BE is, let's say the square side is 2. Because we are dealing with ratios, I could take it whatever I want. I'm taking it 2 because BE will become 1. And BE is 1. Side is 2, BC2, what is opposite 90 in the bigger triangle? BF. So I want to find BF. BF is a hypotenuse of 2 and 1. So sides will be in the ratio 1 is to root 5. Very rarely will sides be a part of question, but areas will definitely be a part of question. So areas is in the ratio 1 is to 5. And this brings us to a big learning. The area of triangle BGE is going to be 1/5 of BFC, 1/5 of triangle BFC, and BFC itself is 1/4 of the square. So one big part which can help you in a lot of questions is the area is going to be 1/4 of the square. This shaded part is going to be 1/4 of the square. 1/20th of the square. This complete part was 1/4, 1/5 of 1/4. So the other one also you could find, but this is not going to be a very important one. Lastly, there's one more pair of similar triangles which could be interesting, that of these adjacent ones. So triangle BGE is also similar to, start with theta, theta 90, 90 minus theta, AGB, triangle AGB. And what is the ratio of these sides? Let's be, okay, what do I know in BGE? Opposite 90 is 1. What do I know in AGB? Opposite 90 is 2. So this is a simple ratio, A is to 2. So what are the areas going to be in the ratio? 1 is to 4. And this is pretty obvious also. Just as these two were similar, right? This one is congruent to BFC. So BGF will be similar to ABE. And what is that ratio? That ratio is again 1 is to 5. So if this area was 1, the bigger one was 5, and so this one will be 4. Right? So this is again a learning which you could take. So let me not extend the session a lot, but let me just quickly do one straight question here. The same construction that we learnt here has been done here in a square. I'm not naming it or so on. Maybe it might not be visible below. So let me just draw it a little shorter. And this construction was done, this was done. Let me finish it off with the other ones also. So all these are midpoints, mind you, I'm not writing it. And now the question is about areas. Now, if you have learnt well enough, student, this is going to be 1/20th of the square. This will also be 1/20th of the square. And I know this lower corner is 1/4. 1/4 is nothing but 5/20. So the total is 5/20. Out of this is 1/20, 1/20. So this will be 3/20. And this all will be 3/20. So this fast you can actually do, students. Right? So this will be 3/20, 1/20, 3/20. And if I want the middle area, can I find the middle area? Absolutely. Let's add up all of them. Let's start from here. 1, 4, 5, 8, 9, 12, 13, 16. 16 out of 20 is done. So this will be 4 out of 20, which is going to be 1/5. Right? That is what you can actually do with knowing scenarios beforehand.